Educational Module. Machine Learning. Learning Unit. Core. Reinforcement Learning. Reinforcement learning is an area of machine learning concerned with how software agents ought to take actions in an environment in order to maximize some notion of cumulative reward. Reinforcement learning is one of four basic machine learning paradigms. Machine learning, also referred to as ML, includes these four different types of learning paradigms. Supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. Reinforcement learning can also be considered an area of the deep learning field, since there exist algorithms that use deep neural networks and deep architectures. The approach of deep reinforcement learning extends reinforcement learning by using a deep neural network and without explicitly designing the state space, e.g. learning Atari games by Google DeepMind. In reinforcement learning, an agent interacts with an environment, often simulated like a game. This interaction provides feedback between the learning system and the interaction at any step in time. The agent modifies its behavior with the awareness of the states, actions taken, and rewards for every time step. The goal is to compose an optimization process in order to maximize the accumulated reward. Reinforcement learning is based on optimizing a value function or a policy. Examples of value function models are Q-learning approaches like deep Q networks. Reinforcement learning algorithms utilize feedback in an environment in the form of positive or negative reinforcement. An agent interacts with an environment. This interaction provides feedback between the learning system and the interaction at any step in time. The agent modifies its behavior with the awareness of the states, actions taken, and rewards for every time step. The goal is to compose an optimization process in order to maximize the accumulated reward. Reinforcement learning is commonly used for training an artificial intelligence system to play a game against a human opponent. It is related to fields such as game theory, control theory, operations research, information theory, simulation-based optimization, multi-agent systems, statistics, and genetic algorithms. Basic reinforcement is modeled as a Markov decision process, a set of environment and agent states. A set of actions of the agent. The agent rules. The reward regarding action. The probability of transition from state to state. Rules are often stochastic. The observation typically involves the scalar, immediate reward associated with the last transition. In many works, the agent is assumed to observe the current environmental state. If not, the agent has partial observability. Sometimes the set of actions available to the agent is restricted. A reinforcement learning agent interacts with its environment in discrete time steps. At each time, the agent receives an observation which typically includes the reward. It then chooses an action from the set of available actions, which is subsequently sent to the environment. The environment moves to a new state and the reward associated with the transition is determined. The goal of a reinforcement learning agent is to collect as much reward as possible. Two elements make reinforcement learning powerful: the use of samples to optimize performance and the use of function approximation to deal with large environments. Thanks to these two key components, reinforcement learning can be used in large environments in the following situations. A model of the environment is known, but an analytic solution is not available. only a simulation model of the environment is given. The only way to collect information about the environment is to interact with it. Reinforcement learning is particularly well suited to problems that include a long-term versus short-term reward trade-off. It has been applied successfully to various problems, including robot control, elevator scheduling, telecommunications, backgammon, checkers and Go, AlphaGo. A prime example of reinforcement learning is AlphaGo. AlphaGo is a computer program that plays the board game Go, one of the most popular board games. It was developed by DeepMind Technologies, which was later acquired by Google. AlphaGo became the first computer Go program to beat a human professional Go player without handicap. The main idea behind most reinforcement learning systems is to train by constantly playing against itself. The more games it plays, the higher its skill rating becomes. A simple example of reinforcement learning would be Atari games, using the OpenAI Gym toolkit. All the program can see is frames from the game, and the only thing the program can control is an input/variable of left or right movement, similarly to how a human player would click either of two buttons on a keyboard to move. Overall, as previously mentioned, the important terms of reinforcement learning are: environment, a scenario that an agent has to face; reward, an immediate return given to an agent when he or she performs specific action or task; state, state refers to the current situation returned by the environment; policy, it is a strategy which applies by the agent to decide the next action based on the current state. There are three approaches to implement a reinforcement learning algorithm. Value-based. In a value-based reinforcement learning method, you should try to maximize a value function. In this method, the agent is expecting a long-term return of the current states under policy. Policy-based. In a policy-based method, you try to come up with such a policy that the action performed in every state helps you to gain maximum reward in the future. Two types of policy-based methods are: deterministic. For any state, the same action is produced by the policy. Stochastic. Every action has a certain probability. Model-based. In this reinforcement learning method, you need to create a virtual model for each environment. The agent learns to perform in that specific environment. Two type of reinforcement learning methods. Positive. It is defined as an event that occurs because of specific behavior. It increases the strength and the frequency of the behavior and impacts positively on the action taken by the agent. This type of reinforcement helps you to maximize performance and sustain change for a more extended period. However, too much reinforcement may lead to over-optimization of state, which can affect the results. Negative. It is defined as strengthening of behavior that occurs because of a negative condition which should have stopped or avoided. It helps you to define the minimum stand of performance. However, the drawback of this method is that it provides enough to meet up the minimum behavior. There are two important learning models in reinforcement learning: Markov decision process and Q-learning. Markov decision process. The mathematical approach for mapping a solution in reinforcement learning is reckoned as a Markov decision process. As a result, we need a decision-making process. A Markov decision process is a discrete time stochastic control process. It provides a mathematical framework for modeling decision-making in situations where outcomes are partly random and partly under the control of a decision maker. Q-learning. It is a value-based method of supplying information to inform which action an agent should take. Q-learning poses an idea of assessing the quality of an action that is taken to move to a state rather than determining the possible value of the state it is being moved to. We are effectively taking into account the quality of the action, and the mathematical equations change in order to quantify the quality of the action accordingly. An additional concept that is introduced is a temporal difference to calculate the Q values with respect to the changes in the environment over time. A better example for Q-learning would the following graph. We assign every edge an instant reward value, and we want edges that lead directly to the goal to have a high reward, in this case a reward of 100. Here we can see same many algorithms and their characteristics. And some additional too. Reinforcement learning has certain shortcomings where using something like supervised learning is a better option. You can't apply reinforcement learning models in all situations, for example when you have enough data to solve the problem with a supervised learning method when there are time and computation constraints. Reinforcement learning is computing heavy and time consuming, especially when the action space is large.